Okay, so I'm back with part 5. So we were talking about the incremental rate of return, and what that is basically the difference between two projects, right? And it's going to tell us the discount rate at which it becomes profitable to switch from one project to the other. So the question is, when do you go from the minor to the major overhaul, right? We got these two projects here, and you'll see it in the graph. The graph we're going to see in a minute will show you very carefully what I'm talking about. So instead of comparing the projects directly, we look at the decision to switch from one to the other using the internal rate of return rule. So here's this example, okay? And let me scroll down a little. I hope I get this right. So we get the internal rate of return. So here's two projects. This one you're shelling out, let's just say $10. I don't know, 10 million, whatever. And this is 50 million. And here's the cash flows. So this is the minor, this is the major. So here's the Excel for the minor. We're getting the internal rate of return. By the way, we're using the rate function, right? You see that? And for internal rate of return. And here's the large project, again using the internal rate of return. So this one says, well, you got a greater internal rate of return. I would do the basically do the minor one there, right? So the question comes down to which project is best, and because the projects had different scales, you can see the size of different scales. You can't compare their internal rates of return. Another pitfall: these things fall apart a lot with internal rate of return. So we compute the incremental internal rate of return of switching from the minor overhaul to the major overhaul. So we first compute the incremental cash flows. So how do I define the incremental cash flows? I'm going to take these cash flows for this project and subtract them from the cash flows from this project. So here's the cash flows for the major, and here's the cash flows from the minor. And here is the incremental. And again, I'm just subtracting. Everyone see that? Just I want to make sure everyone's clear. I then use the internal rate of return again for the incremental cash flow, okay? So this is now 20%. And because this incremental return exceeds the 12% cost of capital, switching to the major overhaul looks attractive. Its larger scale is sufficient to make up for its lower internal rate of return. We can check this result, and now here's the figure I was talking about, which shows the net present value. We look at the net present value profiles all the time. Okay, we always have to look at those for each project. At the 12% cost of capital, the net present value of the major overhaul does indeed exceed that of the minor overhaul, despite its lower internal rate of return. So let's look at the graph, and it's interesting. Notice the crossover point right here. Here is the minor overhaul. Here is the major overhaul. Okay. Notice the incremental internal rate of return we calculated up here is the crossover point of the two projects. You see that? Incremental IRR. And for different discount rates, now notice this. For the cost of capital, the major overhaul is got the higher net present value. Everyone see that? Versus the minor overhaul. So basically, you'd want to do, based on the net present value, you'd want to do the major overhaul. Okay, so you're given false information by what's going on here, by the internal rate of return, and what you do is you just again you got to do a net present value plot and see where the crossover point is. Okay, and at that point, here's the internal rates of return of each individual project. But here's the crossover, and you're less than that. So basically, you would basically do the major overhaul. So at the 12% cost of capital, the net present value of the major overhaul does indeed exceed that of the minor overhaul, despite its low internal rate of return. So, all right. All right, so there's a couple of things that are important here, and common mistakes with internal rate of return and project financing. Because the internal rate of return is not itself a measure of value, it is easy to manipulate by restructuring the project's cash flows. In particular, it is easy to increase the internal rate of return of a project by financing a portion of the initial investment. A common mistake in practice is to regard this higher internal rate of return as an indication that the financing is attractive. For example, consider an investment in new equipment that will have the following cash flows. This is the money you're shelling out, and this is what's coming in. This investment has an internal rate of return of 30%, as you can see. Now suppose that seller of the equipment offers to lend us $80 so that we only need to pay $20 initially in exchange. We must pay $100 in 1 year by financing the project in this way. The cash flow becomes, 50% now, right? So this is higher internal rate of return, meaning that the project is now more attractive. So is this financing a good deal? And again, the answer is no. So, you can go through and read all this, okay? So, although the incremental internal rate of return provides useful information by telling us the discount rate at which our optimal project choice would change, using it as a decision rule is difficult and error-prone. And as they always fall back on, it's much simpler to always use net present value. All right, so I'll end there, and I'll make the final part later on. Okay. I hope everyone stays well.